Howdy. I think we have to talk about geothermal activity, volcanology, earthquakes, and many other things. Maybe some of you are wondering or thinking that I'm just playing around with my microwave, putting there pebbles, and just see what happens. But there is a lot much more to that story. For example, they grow in size. Yes, almost every pebble that did something in the microwave grew, so to say. They came out bigger than they were before. And to me, the analogy, which is very important to understand with my microwave experiments, is that the pebble in the microwave is representing Earth, and the energy source is the sun, nor even the rest of the universe. Once you understand that all the planets of our solar system are confined within the magnetic bubble of the sun, then we understand that we are basically in the pressure chamber of the sun's atmosphere. There is something called the global electric circuit, where we have all kinds of electromagnetic phenomena going on. We have auroral currents, we have the GICs, we have the ionospheric potential, we have the weather systems that are connected, and of course the connection goes on within the Earth's crust. Geomagnetically induced current. Geomagnetically induced currents are electrical currents induced at the Earth's surface by rapid changes in the geomagnetic field caused by space weather events. Geomagnetically induced currents can affect the normal operation of long electrical conductor systems such as electric transmission grids and buried pipelines. Yes, and if they are fairly amplified, they can do a lot more because we have so much conductive materials in Earth's crust. But of course, we are reading Wikipedia. And the predominating paradigm of our modern society that everything is your fault. So if something affects Earth, it's usually seen from a human's perspective. The power grid and the gas pipelines and whatever. But that's just a very, very small part of the whole picture. The geomagnetic disturbances, which include GICs, which induce GICs include geomagnetic storms and substorms, where the most severe disturbances occur at high geomagnetic latitudes. The Earth's magnetic field varies over a wide range of timescales. The longer time variations, typically occurring over decades to millennia, are predominantly the result of dynamo action in the Earth's core. Yeah, I don't believe so. I think there's a plasma at the Earth's core, but we are going with Wikipedia for now. I have plenty of videos where I explain other things, my point of view. You maybe have to check them out first. It's up to you. But anyway, I'm reading what's written here. And yeah, that's it. Geomagnetic variations on timescales of seconds to years also occur due to dynamic processes in the ionosphere, magnetosphere, and heliosphere. These changes are ultimately tied to variations associated with the solar activity or sunspot cycles and are manifestations of space weather. The GIC, the geomagnetically induced current, will create the telluric currents, or earth current is an electric current that flows underground or through the sea, resulting from natural, now it comes again, human-induced causes. Yeah, no. Human activity is almost negligible in these kind of things because, yeah, it doesn't do anything. It doesn't really contribute to the whole picture. But it's Wikipedia, and so we are reading it. These currents have extremely low frequency and traverse large areas nor or at Earth's surface. Earth's crust and mantle are host to telluric currents. Earth's crust and mantle are host to the telluric currents. All right. Caused by changes in Earth's magnetic field due to solar wind interactions with the magnetosphere and solar radiation's effects on the ionosphere, i.e. solar flares. These currents exhibit diurnal patterns flowing towards the sun during the day and towards the geomagnetic poles at night. Both telluric and magnetotelluric methods exploit these currents for subsurface exploration, aiding in activities like geothermal and mineral exploration, petroleum prospecting, fault zone mapping, groundwater assessment, and the study of tectonic plate boundaries. Yeah, there would be so much to talk about this, which I have done already many times. But anyway, the phenomenon has also captured the imagination of authors, finding its way into fiction. Yeah, many science branches nowadays, mainstream science, if you don't repeat their mantra, you are in science fiction. You are not a part of that. So, if you think out of the box, you are not welcome anymore. But anyway, in Umberto Eco's Foucault's Pendulum, the search for a mystic center of the Earth connects to telluric currents, while Thomas Picon's Mason and Dixon incorporates them as enigmatic communication conduits alongside hollow Earth theories. Yeah. I was cutting in half one of the pebbles that has been in the microwave. What did we just read? As enigmatic communication conduits alongside hollow Earth theories. Yeah, there's a hole in the pebble. There might have been some gas, water vapor, or whatever. But now there's a hole. And the thing is, since we are talking about electromagnetic phenomena, they are scalable to very small scales and very big scales. Like I said, to me, the analogy of my microwave experiments is that the pebble in the microwave is Earth, and the microwave is the source of energy. In this case, it would be the sun. And since that's a normal pebble found randomly, basically, and just put in the microwave, it represents Earth literally. So, clay. Clay is a type of fine-grained natural soil material containing clay minerals, hydrous aluminium phyllosilicates, e.g. kaolinite, aluminium, silica, and oxygen. Like a viewer pointed out, that molten glass is a very good conductor. Yes, glass is silica, and there's a lot of this molten glass beneath our feet. Most pure clay minerals are white or light colored, but natural clays show a variety of colors from impurities. Yeah, it's not impure, it's natural. Such as reddish or brownish color from small amounts of iron oxide. Clays develop plasticity when wet but can be hardened through firing. Yeah, that's a different way of heating up things, firing. It's not induced currents. Clay is the longest known ceramic material. Prehistoric humans discovered the useful properties of clay and used it for making pottery. Some of the earliest pottery shards have been dated around 14,000 BCE, and clay tablets were the first known writing medium. So, clay is a very common substance. Shale, formed largely from clay, is the most common sedimentary rock. Okay, so the most common sedimentary rock. Although many naturally occurring deposits include both silts and clays, clays are distinguished from other fine-grained soils by differences in size and mineralogy. Yeah, differentiation. That's why no one understands each other, because everything is differentiated. Silts, which are fine-grained soils that do not include clay minerals, tend to have larger particle size than clays. Mixtures of sand, silt, and less than 40% clay are called loam. Soils high in swelling clays, expansive clay, which are clay minerals that readily expand in volume when they absorb water, are a major challenge in civil engineering. Okay. Readily expand when they absorb water. One very important ingredient in clay is aluminium. Aluminium ore, also known as bauxite, is a naturally occurring mineral rock that contains aluminium in the form of aluminium oxide mixed with various impurities. Bauxite is the primary source of aluminium, which is one of the most abundant elements in the Earth's crust, comprising about 8% by weight. So if we go up quickly here to Earth's electric circuitry, and for everyone who has an induction stove at home, you learned you have to buy a special pan that has an aluminium bottom in order to the induced currents from your stove to heat it up, because aluminium reacts very easily to induced currents. It heats up very easily. So in other words, Earth has a shell made of aluminium, and it receives induction energy all the time. So I think partially, or some of the heat on Earth is not actually coming from the core, it's from the mantle itself, the induced energy from the sun. Okay, now let's go on quickly here down. Aluminium ore, 8% by weight in Earth's crust. And if you start to read about clay, you will stumble across vermiculite. Vermiculite is a hydrous phyllosilicate mineral which undergoes significant expansion when heated. Significant expansion when heated. Yeah, like I said in the beginning, many of the rocks that were in the microwave and did something, they were bigger after they came out. Earth is growing all the time. Sometimes it's growing in jumps. Exfoliation occurs when the mineral is heated sufficiently. Commercial furnaces can routinely produce this effect. Vermiculite forms by weathering or hydrothermal alteration of biotite and flocopite. Large commercial vermiculite mines exist in the United States, Russia, South Africa, China, and Brazil. Yeah, but vermiculite occurs in many places, basically everywhere where you have clay. Now here on Wikipedia, I made now screenshots because this is, I don't know, 5th time I tried to make this video. You have those blue things where you can click on. I tried to make it on a computer, but didn't work. The audio was always mixed up for some reasons. Anyway, I want to get this message out because this is something very important for everyone, because we are sharing the same home, planet Earth. We are all Earthlings, no matter what you believe in, no matter whatsoever. We are the same. We share the same home. We have to be kind to each other, sharing, understanding new findings in order to get a grip of what's going on a bigger scale. Something very important to do. And I guess many of you are aware of the seismic crisis, of the volcanic crisis, and I'm talking about natural occurrences that are going on. We are at solar maximum and these kind of things. It affects everybody because we are walking on the same planet. Anyway, vermiculite, hydrous phyllosilicate mineral. Hydrous. In chemistry, a hydrate is a substance that contains water or its constituent elements. The chemical state of the water varies widely. The chemical state of the water varies widely between different classes of hydrates, some of which were so labeled before the chemical structure was understood. Phyllosilicate. Silicate minerals are rock-forming minerals made up of silicate groups. They are the largest and most important class of minerals and make up approximately 90% of Earth's crust. Hopefully by now you understand what I mean. This is a very important message I try to get across. 90% of Earth's crust, so it affects almost all of us. And now we have to talk about rather specific things. It's basically about the aluminium. And now, as you learned about vermiculite, they grow in size. Yeah, like Earth does. It's growing. Here you have a so-called plate tectonic boundary or a fault. Yeah, because Earth is growing. The continents don't go anywhere. They are getting lifted up, or sometimes they collapse because there are cavities and caves beneath our feet. Some of them are filled with water, some of them are not. And if you ever watch this kind of cave exploration, like dudes are climbing into caves, I recommend to every one of you, go to find a video on YouTube and watch it. And I bet sooner or later, as they go deeper and deeper into the cave, they will find water. And that's a very important point because I think Earth produces its own water all the time. With this being said, for those who are familiar with my mountain water theory, what I think is about the water and the mountains, now we learn there's a lot of aluminium in Earth's crust and stuff, and aluminium gets heated up easily with induced currents, and we have the telluric currents that flow within Earth's crust. The mountain water theory, in a nutshell, is that glaciers are lava streams made of water. In other words, the mountain that carries the glacier is a volcano. Water is very abundant on Earth, so we probably would have to expect one of the most eruptive material we have on Earth is water. There is so much confusion in science about is a quake tectonic in nature Or is a quake volcanic in nature? And yeah, we have those hot springs there. They are not related to volcanic activities at all because it's just geothermal activity. In my opinion, every water source, wherever you find water pouring out of a mountain or out of the ground or at the bottom of the sea, it's all volcanic. And if the water is liquid, i.e., 0.1 degree Celsius, it's geothermal potential. It is a very low potential, but it's still geothermal potential. And every geothermal potential degree is volcanic in nature. Like the example we had in the Yellowstone Park some months ago, where people were walking on those wooden pathways there and watching the geysers, and all of a sudden they had to run for their lives because there has been a big eruption from some of the geysers, and lo and behold, there wasn't just anymore just water coming out of the ground, there was rocks and mud. Yeah. So in other words, in places where we just have a very nice water spring pouring out of the rock somewhere, there is a possibility that one day it either dries up for a while or there's a whole lot more water coming out of there. And if there's a sufficient amount of water coming out of the rock, you might expect it will drag some other stuff with it, material, mud flow, and it might heat up over time. So it is volcanic in nature. So every water source, spring, or whatever you will find anywhere on Earth is a volcanic phenomena or feature. So I am really tired of all those people on YouTube or wherever, all those geologists or whoever people are talking about those ongoing volcanic activities. Visit Greece or wherever. Yeah, tectonic, volcanic. No, it's all the same. Earth is one huge volcano. That's it. Wherever you experience an earthquake, it is volcanic in nature. If there's water coming out somewhere, it is a volcanic feature. If you have lava coming out, it's the same thing. And now I'm gonna try to make a point that undermines what I'm trying to explain you. The chemical constituency of the so-called microwave pebble, this one here, according to Raman microscope, and this data got obtained by the Finnish Geological Survey of Finland. Aluminium, 28.8%. Yeah, there's other stuff, silica, iron, potassium and calcium as well. But it's about the aluminium. Why? Because I made two tables, this is the first one. Top 10 aluminium-rich rock types. Bauxite 40 to 60% aluminium. Shale 15 to 30% aluminium. Claystone 15 to 28%. Schist 15 to 25. Granite 13 to 20. Slate 12 to 20%. Gneiss 10 to 18%. Basalt 10 to 16. Mudstone 10 to 15. Diorite 9 to 14% aluminium. Now, just think of it. Many of those rocks, they are getting wet every now and then due to rain, snow melt and stuff like that. And water is a very important thing. So water is connecting all the things. Water makes the electricity flow. Now let's have a look at the next table, which is, I think, not only not very good looking, but it is very, very important, and I hope it makes at least some people think. Because since I have been in this petrological laboratory, and I was back then quite much about the sulfur and copper, and then I came back with my microwave pebble, and there wasn't any sulfur or any copper in that pebble, or at least not to the Raman microscope. I had to think for a while. But some time ago, I figured to make this table, expanded geochemical summary table of aluminium content from different sources, terrestrial and extraterrestrial. And this is the most important column. We are basically watching it. It's the aluminium content. Yeah, of course we have silica here as well, but it's basically not that important. Here we have the microwave pebble, 28.8% aluminium. Ryugu asteroid, near-Earth object, 12% aluminium. Orgueil meteorite, France, 18%. Comet 67P, 15% aluminium. Caspian mud volcano, Azerbaijan, 18%. Yeah, here on the back side there's like other notable compounds, but we are not talking about these. So maybe we could just zoom in a little bit, because these are the important things we are looking at. This is what I wanted to show you. Caspian mud volcano, 18% aluminium. Lucy mud volcano, Indonesia, 14%. Northern Italy mud volcano, 16.5%. Yes, there are, some 25 mud volcanoes in northern Italy, for those who don't know about this. I've been talking about these. Iceland lava, 15%. Hawaiian ash, 14% aluminium. Mount Etna, Italy, lava, 14.5%. Mount St. Helens lava, 18%. Kilauea lava, 13%. Brazilian clay, 20%. Martian clay, analog simulated environment. Yeah, that's from Mars, 18%. Aluminium. Turkish bentonite clay, 19.5%. Olaguil volcano lava, Chile, Bolivian border, 17% aluminium. Resolution Guyot basalt, 16% aluminium. Limalok Guyot basalt, Pacific Ocean, 15.5%. Itamai Thai seamount basalt, 14% aluminium. Ethiopian kaolin clay, 32.88%. Rift Valley lava, Ethiopian Rift Valley, 15.2%. Dalol mud deposits, 14% aluminium. Afar region volcanic ash, 16%. Yeah, that's Ethiopia as well. Corensite clay, Veitsivara, Eastern Finland, 22.5%. Kaolinite rich clay, Kainu, also Finland, 28%. Illite clay, Kuopio, 19% aluminium. Supracrustal rock, Skuovila, southern Finland, 16% clay. Kiviniemi ferrodiorite, eastern Finland, 18.5%. Argent tonalite, Nurmespel, eastern Finland, 17.5%. Aluminium. Outokumpu serpentinite, Outokumpu, eastern Finland. Yeah, which is just a stone throw away from here. 12% aluminium. Yeah, copper. So in other words, clay and lava, not only are they coming from beneath our feet through to eruption features, but we find them also on asteroids. And here, for example, we have a nice example. Mud volcano, Icelandic lava, and Hawaiian ash. 14, 15, 65, 14. There are slight differences in other components of those materials. But my point is, it is about the aluminium, because we are looking at Earth's crust, mechanics on Earth's crust. And the thing is, once you understand that lava and clay are the same thing except for the water content. Red hot lava really doesn't contain a lot of water. But if you take lava, cool it down, smash it with a hammer and mix it up with water, you get clay. It's the same thing. And we have Earth as a conductor in space. Its shell contains a lot of aluminium and many other conductive materials, copper, iron, gold, and whatever. Combined with all the water, that is even more the more conductive agent because it is somewhere everywhere. Yeah, so the heat, I think, is to some degree generated within the Earth's crust or mantle, like in the upper layer. No need for the core. Because, for example, aluminium gets heated up very easily. We have vermiculite, for example, that makes stuff expand when heated up. That's where we get the land uplift. Maybe also some gases and stuff like this. But lava and clay is the same thing. Same thing. Let's put it this way. Lava equals clay. How to write clay again. This is what I found out some time ago. And I really would like to hear back from you. What do you think? It's in a way very hard to debunk it because there are many examples here where you can compare, you can make screenshots, make your own research. Here is the reference list for where I picked up the data. Yeah. So that's the thing about plate tectonics, volcanic activity, earthquakes, lavas, clays. It's all one thing. We need to get a holistic picture of the whole. Otherwise, you will just wander around in this one corner of the room and you will never figure out that, really, there's a door you can go to another room? No, because you're just catched up in this one corner. I don't get any money out of this, but if you know someone who could be interested in that, share this. This is an important message to everyone, scientist or not. And I really would get some feedback from whoever. You will find my email address. Just go to my papers, you will figure it out. And if someone doesn't believe or disagrees, then I really would like to see him debunking my theory. As long as it is not possible to debunk this, yeah, you might have a problem. It's not a problem for me, it's a problem for you. But that's important. We are at solar maximum. There is an obvious increase in seismic activity all over the place, which is volcanic in nature. And this also ties to weather. Telluric currents are influencing the weather and so on and so on. Bad weather means the crops are not growing. This means there's no food. And if there's no food, it's going to be a bad thing. And it doesn't matter in what you believe in. Once you get hungry, you will figure it out. Yeah. It's about the food. It's not about how you look. It's not about your gender. It's not about whatever stuff. It's not about the brand of your car. It's not about having a car or not having a car. Once you get hungry, you have a problem. And this is how all these things are affecting all the other things. Earth's crust contains so much aluminium. Earth's crust contains so much water. There's so much currents flowing through everything. Yes, they will affect everything on top of Earth's crust. And Earth is the only home we have. The only home we will ever have. So take care of each other. Learn as much as possible. Thank you. Bye.